My name is Dan Wynn. I lead engineering for Amazon Simple Storage Service, or Amazon S3. I'm going to be joined on stage today by Kawaja Shams from the NASA Jet Propulsion Laboratory. And we're going to be talking about putting Amazon S3 to use. So you've heard probably a bunch about S3 in various keynotes and talks already. In today's session, we are going to learn how to put it to use towards some concrete business and engineering objectives. First, we'll learn to write a simple app on S3. So we'll go into the management console, we'll create a bucket, and then we'll fire up an IDE and write our first application against S3, putting objects, getting objects. We'll then step through learning to enable selective, secure access to your objects. We'll talk about how to protect yourself using S3 from errors in the application or operator error. We'll look at how you can save money on S3 by archiving data to cheaper archival storage and eventually aging it out with expiration. And finally, we'll look at how you can run entire websites on S3, saving both time in terms of management and money in terms of the infrastructure you run to do it. Before we dive into each of these areas, I want to pass over to Kawaja and let him talk about how NASA is using S3 for all these purposes and some others as well.
Okay. All right, so just a sample application that I want to talk to you guys about today is for the Mars exploration rovers. These are the rovers that have been on Mars since 2004. These rovers were supposed to last for 90 days, except they ended up going for 8 years, and they're still going. And some of our data started getting really big, and some of our internal infrastructure started kind of crumbling under the amount of data that we had to hold on to. And so we started looking for ways to migrate our data processing, data storage, and data delivery mechanisms via S3. So all of the images that are coming down from the rover are now actually stored on S3. And as soon as we do that, we're able to enjoy the durability that we get out of the 11 nines of durability that we get out of storing the images in S3. But also, now all of a sudden, we have web-based URLs that we can provide to people with links to the images, especially the images that are, that we want our scientists to be able to collaborate around. More importantly, all the plans that the scientists made for what the rover is going to do the next day are stored in S3. A lot of people think Mars rovers are operated out of joysticks. Unfortunately, you can't do that because at the speed of light, it takes 7 minutes to get to Mars. So what we do is we actually decide what the rover is going to do over an entire day, and we put that in a plan, and we send that over to the rover. So all these plans are stored on S3, and scientists collaborate around these plans in terms of, one scientist will upload the plan, the other scientist will download these plans, edit it, and then work through that life cycle. Now, these plans are sensitive data because they have some of our sensitive activities the names of activities that we don't want to get out in case somebody wants to hack our systems. So this is sensitive data, and in order to do that, we do on-site encryption. So before our client application uploads these data onto S3, it will actually encrypt it on site. And then when it downloads the encrypted files, it will decrypt the data on the application itself. So this allows us to keep sensitive information on S3 by encrypting on-premise, which I think is a pretty good design pattern because it allows us to enjoy the low operations cost, high durability, high availability for our sensitive applications without having to compromise the integrity or the privacy of our data.
Cool. Thank you. Let's see. OK, so now that we've heard a little about what JPL is doing on S3, let's learn how we'll write our first app on it. We're going to use a few tools to do that. One is the management console. And if you're, I see lots of laptops in the audience. So if you have one, follow along. Nothing we're going to do here is something that you can't do right now in the room. And then the other tool that we'll use is the SDK and the Eclipse plugin. So with that, let's flip over. OK, so this is the Amazon S3 console. It's at console.aws.amazon.com/S3. You can find it off the AWS main portal page. And here you can see we've got 3 buckets on the left. We're going to create a new one. And I'm presented with 2 choices here. One is a bucket name. And the bucket name is a globally unique name. It's actually going to provide you ultimately with a URL that you can access your data through, which will be bucketname.s3amazonaws.com. So we'll pick, let's say we pick reinvent app. And then the next question we are prompted with is a choice of region. So AWS has clusters of facilities in different regions all over the world. And there are kind of roughly 3 reasons to pick a region. One is regulatory compliance. So for instance, if you are building an application in the EU and you're storing customer data, you're required by law to keep that data in the EU. So you can use our EU region in Ireland. There are other regulations that might require to use other regions. Another reason to choose a region is latency. So if most of your customers are in the US, it would make sense to choose a bucket that is based in the US to provide lower latency access to the facilities that store that data. And then the third reason to choose a region is price. So we reflect the cost of our underlying infrastructure and the pricing of our services in different regions. In some parts of the world, it's more expensive to run our services than others, and we price accordingly. So you can pick based on those 3 things. For today's purposes, we're going to pick US standard. And then we're going to choose to set up logging. This is kind of optional. We could have just said create bucket, but we're going to set up logging here. And what logging does is it writes objects into my S3 bucket that are records of all access to the bucket. So every get, every put, every list against the bucket gets recorded in objects that are then written to the bucket. And I can choose where they go. So I'll enable logging. I'll pick where I want to write. I can write to the bucket I'm creating, or I could write to a different already existing bucket. In this case, I'll put it in the bucket that I'm creating. And then I can choose a prefix. Now, a common mistake actually here is not specifying a prefix. And what you end up with there, if you do that, is a bunch of logs in the root of your bucket, which makes it a little harder to navigate and see. So what we're going to do is say something like logs /. So then all our logs will end up under a log prefix. And we'll go ahead and create that bucket. OK, so now I've got my bucket reinvent app. It's an empty bucket for the moment. And at this point, we're going to fire up the Eclipse IDE. So this is a dev environment. You can develop against AWS actually from all sorts of environments. And we've got a page actually, aws.amazon.com/code. Again, you can find this right off the portal. It's easy. But has links to all of our SDKs and plugins. So if you're a PHP developer, we've got a plugin. We've got an SDK for you. If you're a .NET person, we've got an SDK for you. Today, we're going to use the SDK for Java, actually, in Eclipse. So we'll flip over there. And we'll create a new project. And once you've installed the Java SDK and the Eclipse plugin in this case, it becomes really easy to create an Amazon or an AWS Java project. So I'll just click on that and say next. And at this point, I'm going to name it. So we'll call it reinvent-01. And the first thing I do here is I supply credentials. Now, once you've done this once, you never have to think about it again if you're using one account. But you click through to configure credentials, and you'll have an access key, and you'll enter your secret key as well. If you don't know those offhand or have them written down somewhere, there's a little link here where you can easily go find your credentials using your account login. So we'll hit OK. And then we'll add some sample code. So you don't have to add sample code, and you can just write from scratch. But for the first time you write an application, and maybe a few times thereafter, the easiest way to do this is literally just add some sample code in and then play from there. And that's what we're going to do right now. So we'll add some Amazon S3 sample code, and we'll hit Finish. Now at this point, I've got a little project off here. I can drill into the source, the default package, and S3 sample Java. OK. So now I've got source code here. Let's give it a little more space. OK, and we're going to step through the code here to see what it does. So my main right here, first thing it does is creates an S3 client. And what it's doing there, it passes in to create that S3 client. We're going to use that to interact with S3. We associate our credentials with it. And the credentials that we're using are in a little side file that was created by that process that we followed when we created the project. I'm not going to show the credentials since you'll end up in my account if I do that. And then we'll pick a bucket. Now, the sample uses a random bucket, or actually creates a random bucket. But we've already created one. So we'll say reinvent-app. And we'll stick with the name of the key there. And we'll flip down through the sample code here. And we've got a line for creating a bucket, which we don't need to do since we already created ours. But creating a bucket using the SDK is literally as simple as S3, which is the object name we created for the connection, S3.createBucket, and then the name of the bucket you want to create. So we'll comment that out since we already got our bucket. And then the next thing we can do is list buckets. So there are two kinds of lists in S3. One is listing your buckets, and the other is listing your objects. You'll sometimes hear the request for listing buckets called a lam request, or a list all my buckets. And this command here is list buckets. So S3 list buckets returns an enumeration of all the buckets in your account. And then you can drill into them with code like bucket.getName. So really simple mechanism for looking at the buckets. All right, so we'll go down. We've got our bucket. We've listed the buckets. And we're going to upload an object into our existing bucket. So we've got code right here that is as simple as S3 put object. And then I specify a bucket name, which is going to be reInvent app, a key name, which we specified in our code up above as my object key, and then the content of that key. So objects in S3 are essentially key value pairs. The key is the name of the object. You use it to access it. And then there's a blob, binary data that you associate with the object. We've got a little helper function here which produces some text that will get pushed into that, which is the create sample file there. You could easily swap that out for whatever content you wanted to put in the object. Go down from there, and get object is basically as simple. So it's S3 get object. In this case, you don't have to specify the content because you're retrieving the content. So you just specify the bucket name and the key name. And then once you've got that object, you can pull out things like object metadata and the object content. All right. So we've got the code for a put. We've got the code for a get. And now we'll move on to listing objects. So we've got a simple API here, which is S3 list objects. And we'll list all of the objects in your bucket. And it'll provide an enumeration of those objects which we can drill into with code like object summary get key. Now you'll notice here that on the list objects command, I have specified, or the code actually specifies, the bucket name and a prefix. So your bucket might have billions of objects in it. To start in your first app, it'll probably have hundreds or thousands maybe. But you don't want to list through all of those when you perform a list operation. So you'll specify a prefix that will scope the list command just to a set of objects within a prefix. OK, now we've also got some code here for deleting an object, which we're going to comment out since we want to keep it once we've put it. And in the sample, we've got some code for deleting the bucket.
I would pay attention to the fact that there's a comment up there that says if you've got a lot of objects in your bucket, so let's say you've got more than 1,000 objects, your results will be truncated. So if you list the objects and you don't see an object you're looking for, make sure to go and look at the next batch of objects.
Yep, well, each list will actually return up to 1,000 entries, and you can specify if you want it to return less. You could say list 100 objects, and then you step through listing iteratively 100 or 1,000 objects. OK, so now we've got some working code. Let's fire it up and see what happens. So listing buckets, we've got the 4 buckets that are in my account. We upload the new object. We downloaded it and print the content. You can see the ABC is kind of the sample content that got put into that object. And then we listed our objects, and we've only got the one key there, my object key. So now that we've done that, let's actually go back and look at our bucket in the management console. So we've got reInvent app, which was empty before. We'll hit refresh on it. And now we can see that key that we just wrote the code to put into the bucket. So at this point, we've got our first very simple application. And you can imagine taking this code and modifying it to all sorts of ends. So from there,
but actually also add to the fact that Dan just coded up a program that was uploading files or modifying files on the bucket, and all of a sudden somebody else that you have in your organization who doesn't want to write code but needs access to these files can just download their favorite S3 console application or log into the Amazon Management Console and get access to all of those files without having to write a single piece of program.
Yeah, absolutely. So let's talk about actually how we can enable them to do that securely,
okay,
which is our next step. So actually, well, before we go on from that, so takeaways from what we just did. AWS has SDKs for every platform, or at least a majority of the big platforms. And the S3 API is really simple. It is put object, get object, list object, essentially. You can delete object, delete bucket, create bucket, etc. And choose your bucket, when you create your bucket, when you create your bucket, choose your region based on three things: latency, regulatory issues, and cost. Okay, so now to selectively enabling access. So Kawaja talked about, once our application puts an object into the bucket, there are all sorts of tools that you can actually use to enable not just developers, but information workers to go get access to that data. Now, you want to do that securely. AWS buckets, or Amazon S3 buckets, start off being kind of secure by default, where anything that you put into it is accessible only by the account that owns that bucket. But if we want, we can start to broaden access in a selective way. So let's look at how we do that. We'll flip back into the management console, and we'll look at my object key, which our app put a moment ago. We'll bring up properties for it. And we'll notice here that the object actually has a URL that you can use to access it over the internet. But if I fire up that URL, I'm going to get an access denied right now. Because the object is secure in the S3 bucket. You don't have access to it. But if I wanted to enable public access to this, I can simply go to permissions on this object, and I can add more permissions. So in this case, I'm just going to open it up publicly for download, and we'll save that permission. Now, once I've done that, I can flip back to the URL for the object, open it, and boom, I've got my content. And now this object, this URL, is accessible to anyone. I can hand this URL to a colleague and have them access it from anywhere. Now, public access is one thing, but probably, frankly, more practical in business and enterprise environments is secure selective access. So I can do that in a few ways. And we're going to look at two different approaches to this, or actually two different approaches to this, both policy-based. So we can create policies that apply to users we create or to buckets that we have in S3. And we can define policy that enables different users to have access at different times from different IP ranges and to different parts of my bucket. So let's look at what it takes to create a user that will have access to one part of this bucket. So to do that, we're going to flip over to the IAM, the Identity and Access Management console. And we're going to click on Users and create a new user. And create a new user, Bob. Now, once I've created this user, they get access credentials, just like an account, but this user is within my account. So I can create within my account as many users as I want. They get their own access credentials, and I can define access for this user specifically. In this account, I've got this access key and secret access key. And this is my one shot, actually, for downloading these credentials. So I should click on Download Credentials and squirrel them away so that I can provide them to Bob. And then we'll close the window here. So now I've got this user who has no rights to do anything in my account at all right now. If Bob, or if we were to use the access key and secret key from Bob's user to attempt to access the reInvent app bucket, we'd get a failure. So we're going to create some permissions for this guy by attaching a user policy. Now, there are a bunch of policy templates, but there's also a policy generator. So we're going to flip to that. And we're going to create a policy that allows access to an Amazon S3 resource. And then we get to pick what kind of access we're allowing. And there are lots of different actions here, right? So create bucket policy, delete object, get bucket ACL, which is the access control list. In this case, we're going to give Bob just get object privileges, which is right here. And then we're going to specify a resource that Bob should have access to. And we do that using an ARN format. So it's ARN : and you've got the little helper there you can use. ARN AWS S3 And then we're going to specify the bucket name, which was reinvent-app. And then we're going to specify a particular part of the bucket from which we want Bob to have access. So we're going to specify a key prefix, docs/Bob, where Bob will be able to get objects.
/star?
Yes. Thank you. Go ahead and add the statement and continue. Now the policy generator generates a policy here. We've got this policy language, which we can we'll generate for, but then you can manually modify if you want to get a little fancier with it. And we'll apply the policy. Now at this point, the credentials that we created could be used to get objects that exist in our reinvent app bucket under the docs/Bob prefix. We don't have any objects there yet, but in the future when we do, he could access them. Now, the other way that we can create policy is at the...
One more thing. You can also give Bob console access, right?
Say again?
You can also give Bob console access.
Yes, we can.
So in the security credentials part of it, you can give Bob console access. He can log into the console himself.
Yep. Now we'd have to add a few more privileges for him to navigate into the bucket and actually see the objects there. We'd have to let him list the buckets in the account and list the bucket so that he could use the console to navigate in. Now we're back in the bucket, and we're going to look at properties of the bucket. Uh-oh, our network connection. Okay, there we go. And we're going to look at permissions. And we've got a button here for adding bucket policy. So in much the same way that we created policy that was specific to a user, and we could create 1,000 users and apply policy to each of those, so we'd have policy that's scaled with our users, I can create policy that is bucket specific and applies to all users that are accessing it. And so here you could imagine saying something like, I want access to my bucket to happen only within certain time frames. The application is only running during business hours, so I want to allow access only during business hours. Or I want to allow access from particular portions of my network. And to do those things, we have a link to the policy generator here. We also have a bunch of sample policies that you can use to start to just go through and find applicable policies for your environment and modify from there. Now, actually, I'd like to have Kawaja speak about how they use bucket policies at JPL.
Sure. So we've got a lot of collaborative applications that we can use with S3. And if something as simple as people wanting to share large files with each other without having to clog up their mailboxes or to exceed the mailbox limits, we have done things like created bucket policies that only allow access to that bucket from our IP ranges. Right. So this is a sample policy that I've put up here that has 2 IP addresses from the Venetian here. But the point here is that you've got this bucket policy that we have put on a bucket called kbucket, and it's called Mars Data in the resource ARN or AWS S3 Mars Data /star, and anything that comes in from that IP address has access to all of the objects in that bucket. So now, all of the people, so if I were to put an object there, at this point, only those 2 IP addresses are able to access it. So, at this point, I can basically put an object in S3, generate a link, and then send that over to another person who can download the file without having to be limited to the file sizes, maximum file size links in our email process. The other portion you can do is you can create CIDRs. So you can say, OK, here are the IP blocks for my organization. So here are the IP blocks that are going to be able to access this. You can give put access, and you can give get access. So people from your IP range can put objects there and get objects from this location. And that creates a very nice, healthy collaboration environment for us. Right?
Cool.
We can also give individual users access. So when the scientists are trying to collaborate with each other on a particular application or particular project, we give each of those 2 scientists a particular IAM credential so they can log into their favorite console programs. And without us having to write any code, we just generate a couple of credentials. We hand them to the specific scientist, and we say, well, you are allowed to download object from this place. You're allowed to get the list of objects from this directory, and you're allowed to put objects in this directory. And again, without having to write a single piece of code, we have enabled secure access to these resources, and we have given them a collaboration space. So much like a very secure Dropbox configuration, but doing it with our own S3 buckets.
Cool. Okay, so takeaways on securing access to your bucket and enabling selectively access to the public and to folks within your organization. S3 buckets are secure by default. So when you create your bucket and you put an object into it, only the account that created that bucket and that object can access it. Policies provide you an either bucket or user-level mechanism for defining access. And access control lists, the mechanism where we said everyone and then opened it to download, which are an object-level access mechanism. So I can go and specify on specific objects whether I want a particular account to have access or not.
There's one more thing you can do to enable access, which is signed URLs. So with the APIs, you can actually, if you don't want to create a policy, you just want to give somebody a URL that they can use to download the file, you can create a signed URL. And when you're generating the signed URL, you can specify IP addresses that this can be downloaded from and the time ranges. And I'm not sure if you can do the frequency or not.
Not frequency.
Not frequency, but you can specify the IP address and the time range during which it could be downloaded, generate a URL, and send that over to an email. Currently, that does require you to write some code, but again, at this point, I can basically put a file, create a signed URL, and send that over. And we also have some tools that will do that automatically in terms of allowing users to download files without ever giving them access.
Cool. Okay, so now you've got an application, and it's got secure, important information to your business. How do you make sure that you don't mess that data up? We give you put access, which you can use to write over data, and we give you the delete operation. So how do you make sure that your application, that a bug in your application, or that an operator doesn't cause you to lose the data that's important to you? We have a tool called Amazon S3 versioning, and it looks like we don't have a slide there. So we have a tool called versioning, which enables you to. It's a bucket level configuration, which you can specify to keep every version of an object that has ever existed in your bucket. So if I write a key named Dan, and then I overwrite that key named Dan with new data on the following day, and I overwrite it again with new data on the day after that. If I have versioning on, the S3 bucket will actually contain 3 objects. Now, a simple list of the bucket will only show the one. It will show Dan. But if I then apply versioned list, I will actually see all 3, and I can use a versioned get operation to get any one of them. So one of the really nice aspects of that is that if you have an application today that's running on S3, or you write one in the future that's not using versioning, you can turn on versioning, and it doesn't change the behavior of the application at all. Deletes continue to operate the way they normally do. Your list only shows you essentially the current version of the bucket. But if you use the versioned operations on the bucket, you can then dig into past versions of data. And if you want, you can remove, if you decide that you're comfortable, you can start purging older versions by using a versioned delete operation. But this provides you protection from a bug in the application or an operator error in the console or any number of things.
The other tool that works really well with this one as well is the IAM credentials. So when you saw Dan's Eclipse console, Eclipse IDE, the credentials that you put in there should be very restrictive to that application. Don't put your root credentials in your application. Put credentials that are limited to just the bucket and the key space that this particular application is going to work on. That prevents errors like list all my buckets and delete all the files from my first buckets. We've seen things like that happen. But even things like if somebody accidentally puts in the name of the wrong bucket and starts deleting files willy-nilly, then you can get in trouble. Furthermore, you can even restrict things in your application from the IAM credential, like things like, okay, give this credential, give this identity access to delete the file, but don't give them access to delete versions. Or list files, but don't give them access to list versions. And this could be used to cleverly protect yourself and your applications from making a big mess. Yep.
Now you can actually take it a step further and turn on, once you have versioning turned on, you can then also turn on a mechanism called MFA delete, which is multi-factor authentication and requires a token. So like a Gemalto token, which produces a number every 60 seconds. And is physically then added to the API. So this is a mechanism. Actually, I know businesses that store critical business data in S3 and have chosen to turn on versioning and MFA delete and put the token in a vault. so that literally versions cannot be deleted. Now, the regular API continues to operate as normal. The application proceeds as normal. But every version of every object is saved in the bucket, and there's no mechanism without the token for deleting the versions. OK. Next, we'll look at how we can save money on S3 by archiving data and eventually expiring data that we no longer need. So the tools that we'll use here are S3 Glacier, which is a new storage class or it's a new storage mechanism in S3, and object expiration. So imagine that you have an app that generates gigabytes or even terabytes of logs a day. That data is useful to you for a period of time. You go back to it, every so often in the first month or two. But maybe after 3 months, you find you're not really accessing that log data, except for every once in a blue moon. But you don't want to get rid of it. Amazon S3 Glacier and Expiration provide you a mechanism to store the data that you need to actually access regularly in standard storage with rapid access, and then archive the older log data into S3 Glacier, where it will be stored cheaply, but require some time to get access to. So let's take a look at a demo of how we actually do that. So we'll go back to the S3 console here, and we're back in our reInvent app bucket. And under the properties for the bucket, we'll go down to Lifecycle, and we'll click on Add Rule. Now at this point, I can choose to keep it enabled. I can specify a name, and then I can decide whether my rule is going to apply to the entire bucket or just a portion of the bucket. In this case, let's say that I'm interested in archiving just my logs. So I'll specify a prefix, logs, and then I'll look at adding a transition. So adding a transition enables me to specify an age at which objects should move to Glacier. So maybe in this case, I want quick access to logs for 90 days. And after that, I'm OK with them being in archival storage. So I'll specify 90 days here. Now, for the first 90 days of their life, these objects under the logs prefix will be stored in S3 standard storage, which we were excited to announce a big price drop on yesterday. And then after 90 days, they'll be transitioned to Glacier storage, which is dramatically cheaper even than that, at 1 cent per gigabyte for storage. Now, let's say that I also am not interested in keeping these logs beyond a certain point at all. So maybe after a year, I don't need to keep them. So I'll specify an expiration of 365 days. So the behavior here will be objects will be written into the logs prefix. And for the first 90 days, they'll stay in standard. After 90 days, they'll be transitioned to Glacier, and they'll stay in Glacier storage until the object is a year old from its original write. And then at the 365-day mark, we'll delete it automatically for you. And I'll go ahead and hit save. Now, we warn you, because this is kind of an important management operation we're taking here, that objects which are being transitioned into Glacier are not immediately available when you want them. You specify, you issue a restore command, and we bring it back to availability in S3 within 3 to 5 hours. So you can make it available within a few hours, but it will not be accessible immediately to gets. All right, and then the other piece of this is that I'm stating in this policy that I do want my data deleted when it's older than 365 days. OK, so it's going to go ahead and save that. So I'll flip back. Some takeaways here. So S3 Glacier. Glacier is a new service that we're really excited about. And S3 Glacier is the marriage of S3 and Glacier and provides the use of the underlying Glacier storage service while still maintaining the S3 index and the ease of use of archiving objects that you have written in S3 directly into Glacier. Lifecycle rules enable me to automatically move these objects. And once I've archived an object, it's still listable in the S3 API. So I can still list my logs prefix, and it will show me objects of any age. But those objects that are still in S3 standard storage are immediately gettable. And objects that have been transitioned to Glacier require a restore. And then 3 to 5 hours later, I can issue gets like I normally would against those objects. And when I do that restore, actually, I specify a time period that I want that object to remain available in standard S3 storage. Now, a quick little kind of power tip here. If you've got a prefix or a bucket with a really large amount of objects that you want to just quickly delete, you can actually go ahead and set a lifecycle policy that specifies that prefix or that bucket and goes and expires objects in it. Now, be careful with that because it does go doing what you asked it. It does go do what you asked it to do. All right. Now, our last area of focus is effortlessly scaling a static website. So S3 now provides a website feature that enables you to run an entire static site on S3. So if you have a website that you're running specialized infrastructure for, you can potentially dramatically reduce your management time involved with that infrastructure and the cost of running that infrastructure by taking a look at S3 website. So we're going to jump into the console, look at what's involved in configuring that, and then we're going to hear from Kawaja about how JPL is using this with some very complex websites. All right. So we're back in the console. And now we're going to flip over to the website tab. Actually, we're going to create a new bucket for this. So we'll create bucket. And we're going to call this one www.reinventapp.com. And the reason that I'm naming this like a website is that once you've created this bucket and you've set up website, you'll actually be able to, if you own this domain, you can CNAME that domain to S3 and not manage any infrastructure for the root of the site. All right, so I'm going to go ahead and create this bucket. And once I've done that, I'm going to upload my website content to it. So I'll hit upload, and I'll hit add files. And I've got two kind of ready-made files here, error and index. I'll go ahead and upload those. And when I do that, I'm going to set permissions to make everything public. So for the website to work, all the content in that website has to be publicly accessible. And this make everything public instructs the console to set access control lists on each object that's uploaded that enable public access to that data. I'll go ahead and start upload. And it fires them both up. We'll take a quick look at the content of those. So index is just a simple HTML page. And the error is the page that you land on if the URL doesn't exist. So now we've got these two guys uploaded, and we need to tell S3 how to use them. So we'll look at properties for the bucket. And we'll go to website. We'll click enabled, and then we'll specify that the index document for the website is the index.html object that I uploaded, and the error document is the error.html file object that I uploaded. And we'll go ahead and click save. And now at this point, the website is set up. So I can click on this link here for the endpoint, and boom, I've loaded my website. And if a customer were to come to the website and enter a garbage URL, but on this domain, we'll see the error document that I've uploaded. So at this point, we've got a really, really trivial website. Not super exciting in terms of what's being delivered, but you can see the basics in terms of what's involved in just setting it up. It's really simple. And let's hear from Kawaja about actually what you can do with complex sites on this.
Right. At this point also, by the way, you also don't have to worry about running your Apache server and having an operations team or anything like that. For small websites, this works really well because with a couple of clicks, you've got this website up and running in a highly durable environment and a highly available environment. Now, you can actually add even more power to it. So when we started looking at the Mars websites, let me actually see if I have a screenshot. When we started looking at the Mars websites, we quickly noticed that we can run this entire website off of S3. And then as we made this site, we realized that we had a couple of applications here that were dynamic. So what we used was CloudFront behaviors to say, OK, well, CloudFront can get all of the objects from S3 except for the small portion of our site that was dynamic. We routed that portion to an elastic load balancer in the back end. Now, even more importantly than that, we were able to, we started noticing that our dynamic portion under heavy load was exposing a memory leak, and this was on landing day. And we quickly noticed that the more we hit this particular site, it happened to be the index site that was hitting a memory leak. I did not write that code. What was that?
A memory leak in what?
A memory leak in the Cold Fusion code that was written to service the site that, again, I did not write. But the point is that we exposed this memory leak, and as soon as everybody was hitting this index, the main index page, we were exposing this memory leak that was slowly deteriorating the performance of the site and causing the servers and behind the load balancers to kind of lose memory. So we put together a very quick hack. We wrote a little script that would go to our site, get the index.cfm page, and just upload it onto an S3 bucket. And we pointed the CloudFront distribution to just go get the file from the S3 bucket instead. This way, we only got 1 hit per second instead of hundreds of hits per second onto the dynamic server, and we relied on S3's high availability and high scalability to be able to respond to as many requests as we threw at that index page. Now, there's a perception that static pages are boring, but there's a lot you can do with static pages. So this is our Explore Mars experience. So it's Mars JPL NASA Gov/Explore, where you can actually download some very rich 3D experience that are based off of Unity. Now, to power this experience, we've got the Unity plugin that has some very nice 3D capabilities, but what's happening in the back end is it's downloading terrain files from Mars and providing it on the website on this site here. So all those terrain files, basically what the land looks like on Mars in 3D is going to be coming off of S3, and with each individual tile coming from the website feature. So
am I correct that every resource that's involved in the loading of this page is in S3?
That's right.
Cool.
By the way, just because I do want to advertise this, you can also drive the rover around if you click on free drive. Again, we don't have to worry about running our servers, and the people who made this particular experience, they're very much into UI design and making 3D experiences. They didn't really want to have to worry about hosting this anywhere. They really just wanted to be able to, they actually didn't even want to write any back-end code. They really just wanted to drag and drop this. So in order to make this work, we just created them an IAM credentials, gave them console access, and literally they just drag and drop every time they produce these files and terrains. Another site that works very close, similar to this, is the Lunar Mapping and Modeling Project. So the Lunar Mapping and Modeling Project is a collection of all data ever acquired of the moon from any space agency around the world. And so what this allows us to do is to basically give the public access to all the data at the resolution that we can give that away, and you can basically browse what the moon looks like. And what it's doing is it's downloading specific tiles, individual tiles one at a time, and each of these tiles are located in S3. For the data at the highest resolution, or the most recent data, we extensively made use of the signed URLs because we wanted the application to not actually have access to any credentials. This was made before the IAM tokens were available. So what the users do is the application will log into JPL and talk to a RESTful web application server that will just give them signed URLs to grab individual tiles. So the application goes, gets the signed URL, goes to S3 and grabs the tile. And what we have effectively done there is we have delegated the management of a large-scale storage system and the highly available delivery and the scalable delivery of our data all to S3.
Cool. Okay. Where'd our clicker go?
I don't have it.
Neither do I. Can we flip to the next slide? Clicker, there it is. Okay. Okay, so takeaways on websites. Small sites can be hosted for literally pennies a month and are trivial to set up. It literally takes the 2 minutes that we spent doing it on screen here. Large and growing sites will scale effortlessly on S3. Once you've got the site running on S3, you don't have to think about whether you're doing 1 transaction a second or 10,000 transactions a second on the site. It'll just scale seamlessly for you. Okay, and this is the CloudFront config. We just looked at some of this. Okay, so today we learned kind of 5 basic areas. We wrote our first app on S3. We learned to selectively enable access. We've talked about versioning, which enables us to protect yourself from application or operator error. We talked about saving money using archiving and object expiration. And finally, we talked about what you can achieve with the S3 website feature. So some key tools to remember here. Across AWS, actually, the management console is your kind of go-to tool for configuring all of your Amazon or all of your AWS resources, really. And then the SDKs, there's just under aws.amazon.com/code, you've got SDKs for most of the major platforms, and you've got plugins for most of the major IDEs. So whatever language you're operating in today, we've probably got an SDK and a plugin to work for you. And then on Amazon S3 specifically, some things to remember: bucket policies and user policies as well. The versioning feature, Glacier for cheap archival storage of your data, object expiration for eliminating data that you no longer need, and finally the website feature. So with that, we're going to wrap up. We're going to hang out up here for a bit to answer questions, and you can always swing by the S3 booth as well back in the Expo Center. Thanks a lot, folks.